Today I'm going to talk about benzidine, which is a synthetic chemical that was widely used from the 1850s until 1973. Some of the original uses for benzidine were that they were used in textile dyes, meaning that they were colors for wool, cotton, and leather, with over 250 benzidine-based dyes available. It was also used as a rubber compounding agent, used in plastic films, detection of blood, paints, and printing inks. So why was benzidine banned from being produced in the U.S. by OSHA in 1973? Well, workers in the textile businesses who were having high exposure to benzidine were having symptoms that included hematuria, which is blood in the urine, secondary anemia, acute cystitis, acute liver disorders, dermatitis, and painful and irregular urination, as opposed to those who were not working in the textile business with these dyes. There was also a study conducted in rats where they injected 100 milligrams per kilogram of the rat's body weight of benzidine, and concentrations in the tissues and urine and organs was measured at 4 and 12 hours post-injection. They found that the highest levels were found in the stomach, small intestine at 4 hours, and the small intestine and liver at 12 hours. The higher concentration that stayed was in the liver, and this made researchers nervous about the potential carcinogenic effect on humans. Why and how is benzidine still used? Benzidine is still allowed to be produced and used in small quantities for the use in forensics to detect traces of blood on supposedly clean materials, and it's able to not damage DNA. Small amounts are also still used in research labs. But benzidine must be imported from other countries as the EPA and OSHA agencies do not allow it to be produced domestically. This is the 2D chemical structure of benzidine, with the chemical formula being C12H12N2. Its molecular weight is 184.24 grams per mole, and it is classified as an aromatic hydrocarbon. Next is a drawn-out skit to show how benzidine is used in forensic science. The first scene is the set of a crime scene in a house. Then enter 3 police, with one saying, "Another day, another crime." The next one saying, "Looks like the suspect left no DNA or blood." And then the last one saying, "Not so sure about that." Then the first policeman says, "We should take a sample back to the lab, perform a benzidine test." The second one says, "I thought benzidine was banned." And the third policeman says, "It's banned in textile dyes, but not labs. We can test for the presence of blood and build a DNA profile with benzidine and a few other chemicals." So then one of the policemen heads off with a little scrap of the rug from the crime scene to the lab, saying, "I wonder if there's any blood present. Can't see any, but we gotta catch the suspect." Then once inside the lab, the forensic scientist says, "1 benzidine test coming up." And the policeman who brought the sample says, "Thanks, Doc." Then the forensic scientist / chemist, who knows that benzidine is a dangerous chemical to work with, says, "Let's see what we're working with," and pulls out a brochure with benzidine frequently asked questions and a big label reading it's a class 1A carcinogen. Then on the table are certain papers, one saying what to do if the substance is ingested, if it gets in contact with skin, if it gets in the eyes, or if it is inhaled. And another reads what the cleanup procedures are, which is, since it's a powder at room temperature, you would wet that powder and scoop it into the trash to make sure none of the particles are left airborne. And then that you do not dispose of it in the sink because it is toxic to aquatic life. Another reads, it does not burn, but is very combustible. And then the last one reads, what would happen if it was metabolized, which it forms highly toxic and reactive metabolites. And it is a procarcinogen, and it is mutagenic, meaning that it binds to DNA adducts, which is the DNA that is covalently bonded to a chemical, and that chemical binds to it, and it can get damaged and result in abnormal replication. Then the forensic scientist says, let's test. Gotta be careful with this stuff. It can cause bladder cancer. Mask and glove up. Then using the chemicals, as mentioned before, benzidine, hydrogen peroxide, and glacial acetic acid, mix those together, and then adding a couple drops to that sample of fabric from the crime scene. The scientist says, blood present. Now we can build a DNA profile to catch the suspect. And they thought they didn't clean up. Then at the end, the scientist provides a report saying that there was blood present, what type of blood, it was AB positive, and a DNA profile, meaning the blood stain, and then you would find any suspect matches and compare it to this blood stain sequence from this test. And here are the citation slide with all of the links to websites, articles that I found my information on Benzidine for. And then my credit slide with art, direction, editing, and research going to myself. And I hope you found this skit and presentation at the beginning very informative about the synthetic chemical Benzidine that is no longer allowed to be produced in the United States.